All right, lesson 6-3. I think in 6-2 I started talking about logarithms with you. I know that that's a big focus. I know it's a challenging thing because you haven't worked with them that much. So the sooner we talk about them and start getting used to them. So the first problem says solve 2 times x equals 8. Obviously, you guys have done that lots of times. But you get to the next problem, and this is where they're the whole reason, we could have done some other problems here too. I could have asked you to solve this problem using algebra, where you would have added 3. That's how you undo the inverse of it, subtracting. And then when you got to the inverse of multiplying is dividing. But how do you undo this 2 to the x? You don't have a way to do that. You know what it is. 2 times 2 is 4 times another 2 is 8. So you know that the x is 3. But how do you undo it? Like for multiplying, we have dividing. How do you undo this? What operation is it? And that's where this whole thing for a logarithm comes in. And so when your variable's in the exponent, that's when we have to use a log. So log base b of x equals y converts into as an exponent. B, my base here, it doesn't go in order. The x doesn't come next when you write it as exponent. So b to the y equals x. Okay, so that's the basic formula of that. So now they want us to do it here. Rewrite this exponent problem as a log. So you go log, where's my base? The 3 does not go in order, so what comes here is not the 4, just like what's on the 3 here. So it's the 81, and it always equals what's in the exponent. So what's over here alone is the exponent. The base, you know what the base is. Base is on the bottom of the exponent. So the base right here in that match, all that leaves is the 81. That's your answer on the exponent problem right there. All right, so how does log base 10 of 1,000 equals 3 convert to an exponential problem? Where's your base? 10 does not go in order, so it's also one where I think you know it, because 10 times 10 times 10 is 1,000. 3 zeros, 3 zeros. So there is your basics for how to convert them. So what's this mean? So 5 to what power equals 125? Well, you may not know it, but if you have 5 times 5, that's 25, and 5 quarters is $1.25. So it's 3, 2, and 1 more. 3 to what power equals 0? 3 to what power equals 0 is what this is saying. And that's absurd. You can't do that. 3 to no power will ever equal 0. What about this one? This one's a little tricky. 1/4 to what power equals 16? And you may have forgotten this, or you may not have ever learned it very well, but this 4, 1/4 is like 4 to the negative 1. Well, if I raise this to a negative 2, for example, that's 4 to the second is 16. So the other way to do this problem, you can think of it as it needs to be flipped, but it would be a negative 2. So 1/4 to the negative second power is indeed 16. Again, I would think of it as 1/4 is 4 to the negative first power, and then powers multiply. So this is like 4 to the second. But what about this big goofy thing? So log base 2 of 2 to the 8th equals what? Well, remember what we just said. This really is like saying your base 2 to your power equals this 2 to the 8th. Well, what's got to go in the box then? 2 to what power is 2 to the 8th? Well, 8. So that's got to be an 8. This is going to be a lot of places you'll see this as a property. If you have log base 2 of that same base, any number here, and that's the same number there, or even they'll show it like this, log base b of b to the x always equals the x. And then you think again, base to the x has to equal this, so it does make sense. So what do we have here? Reminder that if you have a square root of 16, that the 2 in here is implied. So what about this one? Base 10, if you ever just see a log without any base number written here, it means base 10. So if I say log of 100, that means log base 10 of 100. And what does that mean? Base 10 to some power has to be 100. Well, what power is that? 10 to the second power is 100. Continuing on here, I know I'm going fairly quick, but you can go back and rewatch those if you need them. Log base E. So in the last lesson, we talked about this E number with infinite compounding as being this 2.718 thing, but like pi, its decimals keep going forever. It's irrational. So they just shorthand this to call it the natural log. The natural log. And they write it as ln. So log base E of 200, just like I have here, is the same or written in shorthand as ln natural log, is how it's said, of the 200. So those are just some things that are written a certain way that you have to use sometimes. So this is log base 10 of 100. 10 to what power is 100? 2. Log, remember, this is log base E, natural log, of this E. So E to what power equals E? 1. And over here, this would be log, like log base E of this negative 1.87. So remember, this is like 2.718 to some power and equals a negative number? Huh? How can any positive number to a power? So this is another one of those examples like, you cannot do that. Matter of fact, you're gonna at some point be expected to know that log of anything or the natural log of anything, whatever goes in these boxes, has to be positive. That will affect your domain on any log or natural log. Okay, so whatever is in here, because the base has to be positive. Base on the logs never have a negative base. So since those bases are positive to any power, it will always be positive, is what that's getting at. All right, well, let's solve these then. Whenever you have it to the base to a power and the power contains your exponent, then that is your signal. You've got to write a log to solve it. Or use graphing. You could graph both sides, look for the intersection of the graphs to solve it. But so this is log base 10 of the 25 equals the exponent. So this log base 10 of 25 is just calculator work. Remember, we did it in Desmos where I did log the underscore, shift dash, and the 10 on the calculator. That made it be log base 10. Arrowed to the right to get a 25 up here and then hit enter. That's in Desmos, how I entered it. In case you don't have access to like a separate graphing type of calculator. On my graphing calculator, I hit the green alpha button in the window, and there's something just called log base number 5 there. And you can type those right in to their correct spots so that they even look the same as what we wrote. And so if I did that with what I have up here right now, I've got, for this, I've got 1.39794. There's some more decimals, and then equals x minus 1. Solving for x, got to add that one to the other side. So you're going to have 2.39794 for your final answer on that one. For this one, whenever my variable is in here, or if it's a log with the variable in there, that's my signal that I need to change the problem back into an exponent problem to solve. So remember, this is log base E. So to solve that one, I'm going to do my base E my power exponent 4 equals my 2x plus 3. This is calculator. Look on your calculator for e to the 4, or in decimals, do e to the 4. Then what am I going to do? Subtract the 3. After I do e to the 4 minus 3, and that's gone, then I'm going to do what? Divide by this 2. To get my final answer of, on mine, it's second ln on my calculator, e to the 4th, enter to get that, subtract 3, enter to get that, and divide by 2, and I'm getting 25.799-ish. And I'm going to round it off, so I'll put my approximation symbols in front of there to admit that I rounded it off, in case in a real life problem I would need to be more precise. All right, then when they do seismic activity, you know, like earthquake sort of stuff, they have this formula for calculating the joules and the magnitude, the energy, if you will. So if I have this and then this formula right here, x is my, and the magnitude right up here. All right, so in my problem that I'm being given, I'm given my joules right here, that's my x. So I'm gonna put the number they gave me, the 4.2 times 10 to the 20th in place of that x. Where's the variable I'm trying to solve for? Right here. When it's in the exponent, what do I have to do? Write a log. So log base 10, if you don't want to write the 10, if you can leave it out when it's base 10, it's implied, of my number here. Equals the whole exponent up here. And when I go to solve this, after the left side's just, you know, calculator type of work, I'm going to then subtract the 12 over, and then divide by this 1.5. And that'll give me my m. So here we go. Log calculator of 4.2 times 10 to the 20th, enter. Subtract my 12, enter. Divide by 1.5, enter. 5.7. 4883286. Final answer, locking it in. And that is all there is for our introduction to logarithms.